Ever wondered how to solve a first order linear ODE or ordinary differential equation? I'm going to do that for you now. So y dash, that isn't a 1, that's y dash, means dy dx. And this is at the point when x is 1, y equals 0. So let's first, I'm not going to write it out again fully, but x squared dy dx plus 2xy minus x plus 1. So this is just dy dx. We first want to get dy dx by itself on the left-hand side. So that's going to be, let's do x squared dy dx, which is going to equal minus 2xy plus x minus 1. Then we're going to divide both sides by x squared, so you're going to get dy dx equals minus 2xy plus x minus 1, all divided by x squared, which is gonna break down and simplify. Actually, I'll put it underneath. It's going to simplify because you've got x terms here that are going to be divided through 2 dy dx plus 2y over x equals 1 minus x over x squared. I've skipped a few steps and I've rearranged. You might be thinking, why have I put it in this particularly weirdo order? And that's because this here is the first order linear ordinary differential equation in standard form. So it's in px y equals qx. So I've put this exactly in its standard form. So we're now going to have a little identity that we're going to use. So we're going to use an integrating factor. So the integrating factor is mu x, which equals e to the integration of px in terms of x. So that is going to be, if I take what px is 2 over x, y. That is px is there, 2x. So that's going to be e to the integral of 2 over x dx, which is e to ln x, because we know 1 over x integrated is ln x. That's an identity you need to know. And we can simplify this, because we know through another identity that it equals x squared, because we can have e to the power of ln x squared, e to the ln vanishes, and then we have x squared. You should probably know how to do that. You probably learnt that at school instead of at university. So now we can multiply both sides by x squared. So we've got this equation and we can multiply everything by x squared, and you're going to get x squared dy dx plus 2xy, which equals 1 minus x. So not too dissimilar to what we had in the beginning. However, there are certain factors that have changed to make it positive or negative. But we can simplify this now to even further to d over dx x squared y, which equals 1 minus x. So this part here has been simplified, and the reason for it is because the left-hand side is the derivative of a product. So we've now got this here, and we can go move to the second step, which is going to be integrating it. So let's integrate both sides. Let's integrate the left-hand side and integrate the right-hand side. So if we have an integral of d over dx x squared y equals the integral of 1 minus x. There should be a dx here. and there should be a dx here because that's what we're integrating with respect to. So if we're integrating on the left-hand side, you have an integration of d over dx. So all you're going to do is that's going to disappear and that's going to remain. So you're going to have x squared y. I shouldn't probably use the word disappear. That's factually incorrect. And now we've got a 1 here, which is going to become x when you integrate it. And minus x integrated is x squared over 2 plus c. We're kind of there, but we now need to rearrange that it's in terms of y. So rearranging this so that it's in terms of y is going to be y equals x minus x squared over 2 plus c, all divided by x squared. So now y is then going to become 1 over x minus a half plus c over x squared. But thankfully, we were given in the beginning that. So we know that x is 1, y equals 0. So let's substitute that in. Let's substitute the point in. So you've got 1 over 1 minus a half plus c. And then we've got a 1 squared. This is just going to be equal to c equals minus a half. So now we can take this and let's plug it into here and get our answer. So we've got y in terms of x is 1 over x minus a half minus 1 over 2x squared. There we go. So I think probably the most crucial part is getting it to make it look like this. This is fundamentally the most important part. A lot of people struggle to get that. And then you would use this, which is the integrating factor, to simplify it. Integrating from here is fairly straightforward. And then this part here is elementary. You should have done that at school. But there we go. We've solved a first order linear ODE.